I just wanted to go over the lab real quick, just so that you guys don't feel a little disconnected on the lab. It's not really that, I wouldn't say that the lab itself is very difficult. There's just a few things I want to point out that'll make it a little easier. So first thing is I have, if you haven't had a chance to look at it, I have posted the groups. And so if you go into Canvas, hopefully you can all see this. If you go into Canvas under modules, so if I click on modules, and then you come down to week 2 and 3, you should see Thermocouple Calibration Lab. And when you go in there, this pretty much outlines everything you have to do for the lab. So what I've put in there is the, first off, there's the actual lab description that was in the course pack. This is downloaded directly from the course pack. You can also get this from the information that's posted on the lecture website, because the entire course pack is there also. So I would take a look at this. Now, if we'd had a normal quarter where we were actually meeting in person, we would have had a part B and C that we would do, but that's not easy to do remotely, so we're not. We're just going to focus on the part A of the experiment, which is the calibration of the thermocouples. Now, if you go to Appendix D, the thermocouples, then that just talks about the different properties. It's probably secondary to the lab. I don't think you'll need to look at it, but the only advantage is that it does tell you the difference between, say, a type T, type J, type K. And so there's all types of different thermocouples, and they're essentially the different ones are used for different applications. Usually how hostile the environment is, highly oxidizing environment or very high temperature environment versus your everyday environment. So that's really the differentiation between the two. Now, what we've done in this lab is we're giving you 2 different thermocouples to test. And since you can't actually do the test, I've recorded on this link here the actual experiment, and also the experiment is described in the calibration up here in the actual lab experiment. So if between those 2 things, you should have a pretty good idea of what was done in the lab. And so you're going to want to condense that into an experimental. And so the deliverable for this is a report that you're going to write with each of the 4 group members. And I'll get to the groups in a second, but you're going to want to have the full type of report that you've seen before, where you have an abstract, introduction, experimental, results discussion, and conclusion. Now, the results and discussion can be combined because you're not writing a real long dissertation. So, but generally the way I see results is that's where you're going to put the graph and the table of data and a short explanation of the graph, not the analysis, but just a short explanation. For example, you'll say, this is the graph of temperature versus voltage versus temperature. Apologize. And then you'll describe it there in terms of what actually is the diagram that you're looking at. And then in the discussion, you'll actually describe what the graph actually means. So that's the big difference between results and discussion. Generally, a results section is just presenting the results with very little analysis. The discussion is where you actually analyze the data and describe what it means. So if you commingle the two, it's not the end of the world. We do have these specific sections, and you should understand what the importance is of each of those sections. So for example, the abstract, that is really meant to be a encapsulation of the entire lab in one paragraph. And that and that's it. It should just be one paragraph, no figures, no diagrams. And it's actually probably one of the more difficult things to write, because you are trying to essentially summarize an entire experiment into one paragraph. And so I'll show you the rubric in a second that talks about what the expectations are for each, but in general, an introduction then would encompass the theory, the background, the theory of what you're, essentially, why are you doing the lab? What's the purpose of it? What is the background theory? So you should describe what a thermocouple is, how a thermocouple works. And I mean, again, the physics of thermocouples gets pretty complicated pretty quickly. So I'm not looking for a high level physics description of the D shells and the way that the interacting valence electrons and how that causes the thermocouple to behave. I'm more looking for just a generalized explanation of it. You should also put in some examples. So how are thermocouples used? What are they used for? What are some typical applications? And then you'll get into the reason for your lab, which is to essentially calibrate the two thermocouples that are unknown and for the application. And so the application is written in the lab introduction as you're trying to pick a thermocouple for an ice cream freezer, okay? And you want to determine which one is more sensitive. So you have the results of discussion, and then a conclusion can just be a few short sentences. Generally in the conclusion, a good conclusion will critique its own lab. And so, for example, in the discussion, you will describe the different things in the lab that the limitations, for example. So no lab experiment's perfect, and the better you are at identifying things that aren't, the limitations are, the better, when you write the lab report, because then the reader will say, yeah, they recognize that, for example, that when we were heating the water, that the water was continuously heating, and when we took a temperature measurement, the time between when we took the temperature measurement to when we actually recorded the data, the temperature could have changed. And so things like that, when you're looking at the data and you try to critique it, will help in the overall analysis. So let me show you, let's see, where is it? So here's the data. And I assume everyone can see this, so holler if it's not. So here, there's a huge data file that's on there, and it's got about 10,000 data points. And so I do not want you to plot all the data points. This data is what the polydac would have collected for you during the course of the experiment. And so the important points are here when you start. So you're going to plot temperature. And
we're not actually seeing any of the data. We're still seeing the
two thermocouples, or you don't know what they are. So you're just going to say orange, purple. And so if you hit in Excel, if you hit Control arrow, then it will take you to the next. It'll take you to the next. Oh
my gosh! Hopefully.
Take you to the next.
My video is broken too, so I can't even hold the sign.
Point in there. And so someone raised their hand. Go ahead and speak up if you have a question.
Yeah, we can't see your, we just see canvas. We don't see what, like the data points or anything.
I cannot hear you at all. Let me turn it on. Okay, say it again.
We can't see what we just see your canvas screen still.
Oh, thank you for saying that. I'm sharing. So you don't see the Excel?
No, we don't.
That's just crap. Sorry about that. Well, thank you for saying something. Let me fix that. Do you see it now?
Yes.
Yep. Yeah, thanks.
All right. Good. Okay. All right. Thank you for pointing that out. Sorry. Okay, so so previously when I was talking about the Canvas page and the actual page that had all the stuff on it, you guys could see that right though. You just couldn't see it when I shifted to the data. Is that correct?
correct.
Okay, thank you. All right, so this is the data page. So when you come to the data page, if you click on the data, this is the first temperature point you're going to plot. And then if you hit control arrow down, you don't need to worry about turn on hot plate, but you go hit it again, you'll notice that it's now at 20 degrees. And so this is a note that was taken during the experiment to put a temperature to a voltage. So if you can imagine, the way the experiment works is you have a thermometer and thermocouples in a beaker of water. You slowly heat the water up, and as the water gets hotter, the voltage that the thermocouples are measuring rises. And so when the thermometer reaches 20 degrees, the observer puts in a note that says 20 degrees, and that tells you that at that temperature, this was the voltage that corresponded with that temperature. So the polydac is constantly taking data. And so if we go and hit control down again, we get to, there's the voltage for 25, and then 30, and 35, and so forth. And then it goes all the way to 100. And so you could go all the way to 100 if you want, but the idea then is that when you get to this point, you don't really care about the time, you just care about the voltage. Now you notice that this has an insane amount of points. This is noise. There's no way we're reading to nanovolts or picovolts. So because these are already in millivolts here. So I would say is around this to no more than 3 decimal places. And even that's probably being generous. So when you present your data, just round what you have. Usually what I recommend is take the data point above and below and average them. So what you'll do is, like, say, if you're trying to find the voltage at 55, take these here and average them, and then that will be your respective value. And you'll probably find that it's so close. Like, I mean, and you have to use your judgment. So like on this one, you see 1.525, 525, and then for some reason it goes down to 517, which seems kind of counterintuitive because it's getting hotter. So it does jump around a lot. All right, so that's the data. Okay, let me stop that now. Go back to. All right, so this here, this is just the actual lab write-up. So I'm not going to go through that because I know you guys can read it. This is the actual assignment that you'll read through. And so it's important to look at the context, the audience. So I would recommend is, read through this and think about, what is the purpose of your lab as it's written here. How is what am I essentially looking for? So I've tried to write it out as best as I could so that it would just be I tried to write it as best I could so that it would be sorry, that was a jump call. Anyway, sorry about that. Getting back to this. So again, just go through the whole thing and read it. And what I suspect is, rather than telling you a bunch of stuff right now, it's probably better that you just look at it. And then as you have questions, feel free to drop into office hours. Okay, so the important thing I want to show you is the grading rubric. So this will help you when you're writing the experiment, the report, because it'll tell you kind of what the ideas are when how do I essentially grade it. So I give you this. So the abstracts were 10 points, the introductions were 30, experimentals were 15, results 25, 35, 10, and then you get a total of 125. So what I've done here is I've put in a few ideas, kind of just to give you a hint or an indicator of what I'm looking for. So one of the things is I do want you guys to develop your own style. The way I write isn't the be all end all of how you need to write. And I don't want to either think that I'm not trying to create little parrots of how I do things. What I'd rather is as long as you present the material in a way that can be understood and you have good grammar, good technique, you follow the rules as far as how you put in graphs and figures, then you should be fine. You just want to make sure that you thoroughly explain what the lab's about, give a detailed explanation of the experimental. Remember though, with the experimental, you can leave out general things like you don't need to tell me that the beaker was filled with water, or the computer was plugged in. So things that would be commonly understood, you can leave out of the experimental. The experimental should not be a bulleted list. It should be more written in a paragraph form, and it should include probably a picture. So you can use the picture straight out of the lab write-up from the lab manual, or you can take a screenshot, whatever you want to do, but you should have some kind of a schematic that explains the actual experiment and how it was done. All right. So that's it in a nutshell. I didn't want to take a lot of your time. I just wanted to kind of give you an overview of the lab so that you didn't feel you're going into it cold. Now, as far as the lab groups go, I would recommend that you have groups of 4. Check the groups, make sure that it's correct. Several of you asked for groups, so I went ahead and put you guys together. The ones that you didn't, I just put you together randomly. I'll say that if there's issues within the group, if one person's not pulling their weight or 2 people, then you need to talk to me immediately. That's the best way. Let me be the bad guy. Let me deal with it. Everyone should be pulling their weight in the lab, in the write-up. And I would recommend don't wait until a couple days before the lab report's due to start working on it or to get together. But again, I know you guys have other things you're working on, so you have to broker your time as you see fit. If you can, try to have a group leader or someone who is like the editor. And so what I've seen in the past that's worked well is you assign someone to write maybe the introduction and the conclusion, someone else write the experimental, someone else write the abstract, split it up how you see fit so that it's equal, and then have one person edit it and make sure it flows smoothly so it doesn't look like 4 people wrote 4 different things. So questions? Now don't speak all at once. So I have a couple of chats, so let me answer those. I see them. Okay. Where can we find our lab groups? Any questions on that? You can find your lab groups it's in Excel. There's a spreadsheet in Canvas. Good, someone answered that. It's at the very bottom. Good, okay. So it looks like you guys answered yourself. So I apologize for not catching the chat. I'm using my laptop. It's a little clunky, but it's still my fault. So is that it? Anything else you guys need to know about it, or are we good? All right. Well, I'll assume by the overwhelming response that we know what we're going to do. So, all right. Well, thanks for dropping in, and I will post the due date. The due date is essentially 2 weeks from today. And again, if you have questions, drop into office hours, shoot me an email, whatever. But I think you guys will do fine. All right.
Thank you.
Thank you guys. Have a good day.
Thank you.
All right. Bye-bye.
Thank you.
Thank you.